Hi, this is Ron Cipcic. This is the third segment in a three-part series on cost behavior. In this particular segment, we're going to take a look at short-run cost calculations. Specifically, we'll be looking at three totals: total fixed cost, total variable cost, and total cost. We'll also be looking at three average numbers: average fixed cost, average variable cost, and average total cost. And then we'll be looking at a marginal calculation called marginal cost. I spelled that wrong. Let me get that correctly. There we go. Leave the first I out there. M-A-R-G-I-N-A-L. Now, it's very important up front before we actually get into these calculations to say something about the words total, marginal, and average, because you'll see these words used in economics all the time. Plus you see them used in other sorts of disciplines, business, math, and so on. A total refers to the entire group, in this case the entire group of units. So if we speak of the total cost of producing 40 units, we say absolutely nothing about a particular member of that group. So the word total refers to the entire group. Likewise, the word average refers to the entire group. If we give the average cost of producing 40 units, we say absolutely nothing about a particular member of that group. We do not necessarily say anything about the particular cost of a particular member in that group by giving the average cost number for 40 units. If you want to know the particular cost of a particular unit within the group, in this case a group of units being produced by a firm, you would have to calculate something called marginal cost. Okay, with that understanding in mind, let's go ahead and actually calculate these cost figures. How do you calculate total fixed cost? Let's begin there. Well, in this particular problem, we're drawing off of information that we provided in segments 1 and 2. We said that this particular firm would be using 16 machines in the short run, and that number would not change. So if you take the number of machines and multiply it by the dollar rate paid to use those machines, you're going to get the total fixed cost of using those machines. Remember, the number of machines does not vary in the short run. So 16 machines times a dollar rate of $24 that was given to us is going to give us a total fixed cost of $384. Notice that will not change whether we produce 8 units, 22 units, whether we produce 32 units, 40 units, 45 units, or 47 units. The total fixed cost will remain fixed. It's fixed for a reason. Okay, let's go down to total variable cost. As the term would suggest, total variable cost varies. It varies even in the short run. So if you take the number of workers times the dollar rate paid to these workers, you're going to get the total variable cost. So number of workers could be 0 times a rate of 56, total variable cost of 0. 1 worker times a rate of 56, total variable cost, this is per day, of 56. 2 workers times 56 equals 112, and so on. You can see as we add workers, the rate doesn't change per worker. We pay workers all the same rate. We assume they're all equally qualified, equally motivated, equally drug-free, etc. And therefore, total variable cost is increasing at a constant rate. This is increasing every time by 56. So you could actually fill in an entire table here just by increasing 56 to the total. All right, let's move on. How do you calculate total cost? Well, there's 2 ways to calculate total cost. You could either add together, you could take total fixed and add it to total variable, or you could take total variable and add it to total fixed. That's the associative property in math. Okay, so let's take our total fixed cost, since we calculated it first, add it to our total variable cost, and we get total cost. So, if we have produced no units, check this out. If we have produced no units, we have hired no workers, but we have our machines in place, our total fixed cost would be $384 plus 0, equals a total cost of $384. This points out something that's very important, that at an output rate of 0, you still incur fixed cost. So even at an output rate of 0 in the short run, you have costs. They are your fixed cost. Now, if we continue on here, 384, and we add the first 8 workers that we spoke about back, not the first 8 workers, the first worker, and then we add 8 units as a result of that worker, then when we add that first worker, we add $56 to our total variable cost, and this is going to be what? This is going to be, what is that? That's going to be $440. And then if we add a third worker, it's going to be $384 plus $112. This is going to be $496, and so on. So every time, notice this is a very important little table here. Every time we add a worker, so here's worker, this is worker 0, worker 1, worker 2. Every time we add a worker, our total cost increases again by 56. Why? Because our total cost is made up of a variable component. All right? So we could actually go all the way down to 7 workers, fill this table out. These would go up by 56 every time. Let's keep moving. How do you calculate average fixed cost? Well, any average is the total, the corresponding total divided by Q. So if you take 384 and you divide that by 0, you can't do that. That's undefined. So we can't divide that by 0. We can't get an average fixed cost for 0 units. But as soon as we begin to produce units, let's say we add the first worker and our output jumps to 8. What do we have here? We've got 384 divided by 8, and that's 48. Let's keep going. If we take 384, and remember that number isn't going to change, divide that by 22, that's our output after 2 workers. We're going to get what? We're going to get, what do we get here? We're going to get $17.45. Okay, and what we notice is if the numerator stays constant and the denominator gets what? The denominator gets bigger, then the resulting number has to get what? The resulting number has to get smaller. So as the denominator gets bigger, as we produce more quantity, the average fixed cost decreases. We'll actually see later on that it decreases at a decreasing rate. Okay, let's keep moving. Average fixed cost. Now let's go to average variable cost. Again, take any total, in this case TVC, divide it by Q, and you're going to get the corresponding average, AVC. So if we take total variable cost of 0 and we divide it by 0, we get 0. No, absolutely not. That's undefined. Any number, even 0, divided by 0 is undefined. Let's go down to the next possible choice. Let's say that we add 1 worker to the operation. We produce 8 units. That worker costs us 56. We divide that by 8. What do we get? We get an average variable cost of $7. So each of those 8 units on average cost us $7. Now again, back to my point that I made earlier, 7 doesn't describe the cost of a particular member. It describes the members as members of a what? Members as members of a group. Okay, let's do it one more time. Take 112, add 2 workers. We now have total variable cost of 112. Divide that by 22, and what do we get? We're going to get, if my math is correct, 509. Okay? So any total divided by quantity will give you the corresponding average. Let's keep going. Our last total is going to be our last average is going to be average total cost. How do you get that? You're going to take total cost, divide it by what? Divide it by Q, and that will give us the corresponding average, ATC. There's two ways actually to calculate ATC. You can take the total and divide it by Q to get the average, or you could actually add the two averages that you've calculated together. AFC plus AVC would also have to equal, well, trouble here with my pen, ATC. Okay, so let's skip 0 because that we've already driven that idea home. So let's say that we actually add one worker and our total cost in producing output with one worker is $4.40. So our total cost is $4.40 and we've produced 8 units. Well, what is our average total cost? $55. That would be the same as adding the average fixed cost on that first 8 units plus the average variable cost on those first 8 units. That likewise would give us 55. So if you take the two averages, add them together, you should get the third average, average total cost, or if you take total cost and divide it by Q, you should get the corresponding average. Okay, one thing I recommend is that students actually use this method if they can in the calculation because you won't get a rounding error. Whereas in this particular method over here, you very well may get a rounding error because when you calculate this number, you may round it, and when you calculate this number, you may round it, and when you round both of those numbers and then add them together, you may have a very rounded number here, which may be a penny off from what the number should be. So it's oftentimes wise to actually go at ATC directly, not using two calculations, but to use one calculation, which we use here. Okay, let's go ahead and fill out our table. I want to actually put these in a table for you. So we'll put quantity up here, and let's also put workers in our table. We'll put workers here. So 1 worker, 2 workers, 3 workers, 4 workers, 5 workers, 6 workers. And then we learned back in our second segment that this would 1 worker can produce 8, 2 workers can produce 22, 3 workers can produce 32, 4 workers can produce 40, 5 workers can produce 45, 6 workers can produce what? 47. We won't put the 7th worker in here. And then we want to put in here total fixed cost, total variable cost, total cost, marginal cost, which we haven't calculated yet, average fixed cost, average variable cost, and average total cost. Now, I'm going to very quickly put these numbers into the table. I actually want to use these later on in our analysis. So let me go ahead and put them in. We do want to carry the numbers out to 2 decimal places. It's very easy to fill in this first column because total fixed cost doesn't change. So 384 should be put all the way down this column. Whether you produce 8 units or 47 units, your total fixed cost is fixed. So we'll go ahead and fill those in. Our total variable cost actually varies as we add workers. This is going to be 56, 112, 168. I should leave those I'll leave those dollar signs off so we can move quickly here. 224, 280, and then what do we have? We have 336. If we add these two columns together, we're going to get the total cost column, and we've got those calculations already done, so let me put them in here. 440, 496, 552, 608, 664, 720. Okay? And then we haven't done the marginal cost yet. We'll skip that very quickly here. 48. We'll put our dollars and cents in here. 1745, 12, 960, 853. You should take some time and actually prove to yourself that you can make each and every one of these calculations. We've done these for you, but because we've done these for you doesn't mean that you can do them for yourself. So take the time and actually see that you can do these calculations. You should try to fill out a table like this on your own dime and time. Okay, so let me go ahead and fill in these average variable cost numbers, and then we're actually going to use this data. Look, in the business world today, people are not hired to calculate these numbers. Machines calculate these numbers. So I'm showing you how to calculate these numbers because you need to know what the machine is doing, and by understanding how the calculations are made, you can understand what the concepts are. But you are not going to actually do these calculations in the business world. Computers do these calculations. All right, let's get the average total cost numbers in here. So what do we have? 2255, 1725, 1520, 1476, and what do we have here? 1532. So you, as business students, you do not, and economic students, you are not going to do these calculations in the business world. But you have to understand not only how the calculations are made, but what the behavior of the numbers looks like. And this table represents some behaviors that we're going to try to point out. Now, before we go any further, let's fill in the last column here. Let's do the marginal cost calculation. And marginal cost, really, of all 7 categories of cost, is probably the most important cost calculation, although it's the hardest to actually get in practice. In the real world, it's very, very easy for a firm to determine what the average cost of its production is. It simply takes its total cost, divides it by its Q, and it can get its average. So getting averages are very, very easy in the business world. However, it's very difficult to actually tell what the particular cost of a particular unit is. Kellogg's can tell you what the average cost of a box of cereal is. Very easy number to get at. However, to tell you what the cost of a particular box of cereal is, or a box of cereal within a particular batch, that's a whole different story. So cost systems do a pretty good job of giving us totals and averages, but cost systems many times are lacking in that they cannot give us marginal numbers. However, marginal numbers are actually some of the most important numbers we need. Okay, well, we'll pretend in this case that marginal cost is something easy to calculate. How do you calculate it? Marginal cost is equal to the change in total cost over the change in Q. Notice that when we go from 0, when we add 1 worker, output goes up by 8. We go to 2 workers, output goes up by 14. We go to 3 workers, output goes up by 10. Notice that when we change cost by adding workers, total cost increases at a constant rate of 56. So for instance, when we add the first worker adds 56 to our cost, but the first worker adds 8 to our output rate. So those first 8 units add $7 each in cost. So that refers to units 1 through 8. When we add, let me scroll down here. When we add a second worker, the second worker adds 56 to our cost, but look at this, adds 14 to our output rate. So that second worker adds considerably more to our output than the first worker, and look what happens to our marginal cost. Our marginal cost actually drops to $4 for each of the units produced by that second worker, which would be units what? 9 through 22. Notice that the 4 does not refer to all 22 units. It only refers to the cost of each of the 14 units added by the second worker. That's interesting. Okay, let me move over here. I'm going to try to save some room so I can actually do one more thing with this problem. Let's keep going. Add the third worker. We add 56 to our cost, but we add what? 10 units to our output rate. We go from 22 to 32. Those units what? Those units each add what? $5.60 to our cost. which is what? Referring to units 23 through what? Through 32. We have the fourth worker. The fourth worker adds 56, adds 8 units to our output rate. Each of those units adds 7 to our cost, units 33 through 40. We have the fifth worker. Fifth worker adds what? Fifth worker adds 5 units to our output rate. Each of those units add 1120 to our cost. That 1120 refers to units 41 through what? Through 45. One more time. Add the sixth worker. The sixth worker adds $56 to our cost, but only adds 2 units to our output rate. Those units are very costly. They each add $28 to our cost. So that 28 refers not to all the units. That is not an average cost of all the units. It's not an average cost of all 47 units. It's the marginal cost of units what? 46 and units what? 47. Okay, so something very, very interesting is going on here. Let me show you. Look at this. This was our marginal product number right here. We developed this in segment number 2. We talked about marginal productivity, the productivity of one additional unit of labor. Notice when marginal productivity is going up from 8 to 14, marginal cost is going down. But look at this. When marginal productivity begins to drop, 10, when it's with the third worker, we hit a peak of 14. Then on the third worker, our marginal productivity drops to 10. Then fourth worker, 8. Fifth worker, 5. Sixth worker, 2. Look what our marginal cost does. It jumps from 4 to 560 to 7 to 1120 to 28. Very, very interesting. Very interesting. So there's a relationship going out here. When marginal product is increasing, what's happening? Marginal cost is decreasing. When marginal product is decreasing, marginal cost is increasing. This is very, very important. Different units cost the firm different rates based on the marginal productivity of the labor. Remember, we're paying the labor the same rate. Every worker gets paid 56. Equal workers in terms of quality. Workers of equal quality. Every worker gets paid 56, but adding every worker doesn't add the same amount to our output. Okay, and therefore different units cost different amounts. Let me just close by saying this, that let me ask this question: what's the cost of the 7th unit? Well, the 7th unit is in the range of 1 to 8, so the 7th unit added $7 to our cost. What's the cost of the 17th unit? Well, the 17th unit falls in this range 9 to 22. The 17th unit didn't cost 7, it cost 4. What did the 27th unit cost? Well, it falls in this range 23 to 32. Well, the 27th unit must have added 560 to our cost. Well, what did the 37th unit cost? It falls in this range of 33 to 40. It must have added 7. And then look here, what did the 47th unit cost? It actually cost 28. So the 7th, 17th, 27th, 37th, and 47th units all cost different amounts. They all added a different amount to our total cost. Why? Because the workers who produced those units all had different marginal productivities. Well, I had hoped to cover one more thing in this particular segment, so there is going to have to be an addendum to this. There's going to have to be a segment 4 that we didn't plan on. So we will wrap this segment up here. We've run out of time, and as you know, we really never run out of time, but you probably have better things to do than to keep watching something on cost. And what I will do is I will put together another segment, a follow-up segment that continues on this theme. All right, we'll see you next time.